Okay, so example number 2, and the base file's got all this set up for you. Remember that when you open it, you're going to have to turn this first to true, right? So double click that, let it run. It's going to take a second or two, and then when that's finished, go ahead and click this to true. And you'll probably see what I have on screen, which is this radiation rose. And what we're going to do is take the data coming out of here and customize it, make it something different. I mean, this is a pretty good visualization. It's not bad. But we're going to make a kind of a, say, a thinned down version of it, something a little simpler, something we can use as a base for some custom graphics. Okay. So first thing we'll do is we'll just turn off the preview. Okay. And we're going to grab the points coming out of here first. So it'll be the end points of the rows. And you can see, there they are there. They kind of radiate around in a wobbly way from the center of the building. And let's take a look at the data structure here. So we've got a nested set of data here. So if you zoom out, you'll see that there's 3 sets. And this is giving you the 2 different, the other kind of extremes of the season. So let's turn this on real quick. So this will give us our January, oh, sorry. This is diffuse. This is the same full year, but it's diffuse radiation versus direct radiation. All right, and I'm not trained to explain the huge difference there, so I won't. So we're just going to work with the, the baseline stuff that comes out, which is basically an averaging of how much solar radiation is going to be hitting the site throughout the entire year, and I'm not going to worry about those other 2. So how do we separate, that 0 output so we can ignore the other stuff? We'll head over to Sets, Tree, and Explode Tree, okay? And then go ahead and zoom in and make sure that there's 3 outputs. And then the points that are coming out of the 0, and if we zoom out, you see the other 2 are missing. Yeah, so the points coming out of the 0 index there are the points we're going to work with. And because my building is at the origin point here, I'm just going to go ahead and I'm going to go to Vector and Construct Point. So that'll give me a point at the origin. If your building is somewhere else, you're going to have to customize, set a custom point, or do a volume or area, calculation real quick to find the center point. But I modeled it to 0, 0, so I'm happy with that. But remember that if your building is somewhere off screen, off the center, then you'll have to update this component here. All right. Okay. I'm going to draw a 2-point vector. So I'm going to start basically redrawing the stuff that was coming out in a different way, right? And I need to direct the lines that I'm going to draw. So in this case, the center, or the starting point is going to be here. We're going to draw them toward the center, not away, like we did the first time. All right, and there's our vectors. And I'm going to skip ahead a little and set us up for the next step. So the sorting that I'm going to do is based on a result that I'm looking for, and I'll explain that as we keep going here. So I'm going to go to Sets and find that sort list again. We're going to do a lot of sorting this tutorial set. And the points that I'm going to resort are going to be based on the length values of them. So the distance between the 2 points coming out of this vector here, I'm going to basically take those from small to large, and then I'm going to reorganize all the points so that they're in the same order, right? And this is pretty common stuff, making sure that the data that you're working with is in line with the renumbering of the numeric information. So we're going to copy and paste that, and at this time, still L goes into K, but then V is going to replace that A input there like that. All right, so take a look at that for a second. You can pause it. Make sure you get that right. Okay, and basically the result we're looking for is to draw a line toward this center, but cut it back a little bit so it never really hits the building. And I don't want to do that with a circle. I don't want to put a perfect radius around it. I want it to be relative to the length of the line itself to keep the pattern generally intact, this kind of lumpy pattern. So that we're going to start working off of this K output here, which is actually the resorted lengths. Okay. So we're going to go to Math, grab our min-max. We got to know the boundary of this. the bounds. I'm going to go to sets, domain, sorry, range. That's going to ask us for the domain, which will be that. And then the number of items we need is actually the number of, the number of lengths that we're working with here. So this can come out of whichever output, but I'll keep it clean and I'll put it out of here. And then we have to subtract by 1. So we'll right click on that output L, throw in an expression x minus 1, and go ahead and plug that in like that. So there you go. And now we're going to do some remapping. So we're going to grab that remap component. Probably going to start getting used to this a little bit. The range of values that we're remapping are these. And that's our bound. And then we're going to put a custom target domain on this so we have some adjustability. So we have some way of making modifications as necessary. Okay, so I'm going to throw a couple sliders in here. Just between 0 and 1 should be just fine. And I'll set my values to like 0.8, just over 0.8 and maybe around 0.1, something like that. Yeah, that should work. All right. Now what I'm going to do is go to curve, grab a line STL component. We used one of these before. The start point of this is going to be the A, right? Remember these points that we resorted? I'm going to turn that off and bring them out of the A output here. Okay, so that's going to be the centers, or the start points. The directions are the vectors that we resorted. Okay, so those two things are related. And if we zoom in really, really close, we can start seeing that there's some lines being drawn at a length of 1 by default toward the center point. Okay, and now we're going to use this to set the custom lengths. But before we do that, this actually is set up actually as a factor, as a multiplier of the length itself. If we just, it's a little easier to control it that way in my mind than just subtracting, because the straight subtraction is only going to give you a perfect circle around this as a radius, as a kind of halo. But this will actually be we're going to use this to multiply the length by a certain factor of itself to shorten it. So what we need to do is go to math, multiply. We're going to multiply this value by the original value, which are coming out of k. All right. So this gets a little confusing, so go ahead and feel free to pause it to make sure you got everything lined up right. All the k's going over here. The only a is going into the direction, and so on. And then we can go ahead and plug that in there. So now you can see we've got lines being drawn. They're following. I'm going to go to plan view. A little easier to zoom around here. Yeah, it's following the general, pattern. The longest one's still going to be the longest one. The shortest one will still be the shortest one. Okay, and I can make some adjustments to that as I feel the need. But even so, this will always still be the longest one, and that'll still be the shortest one, regardless of what I do to these little custom domains here. All right, and that sets me up with a nice little halo, I think, around it. It really it puts a lot of the concentration over where the radiation, the solar radiation, is going to be at its maximum, and for me, that makes a lot of sense. And we can set line weight to support that as well. I'm also going to turn off some previewing here. We don't necessarily need to see those endpoints. Okay. Okay, we're going to add some custom colors to this. Knowing that we've got some colors coming out of here, we kind of want to match it, but we're going to redraw them in our own way using a gradient, custom gradient. All right, first things first here, let's grab our gradient tool and we can kind of work backwards. All right, so I'm going to grab one of these. These are our values. All right, so these are the length values that are proportional to the data that came out of the analysis. And remember, it's an abstraction now. It doesn't really matter when it comes to the length of these lines that it's the exact value of radiation, because that number is much higher than the graphic is going to allow. That number coming straight out of here, let's see, rows endpoints, yeah, rows values, for example. the number, so this value of radiation is interesting, and it's been related to, just by default through this graphic, it's been related to the length of a line and the width of the line, and that's what these endpoints allow us to kind of experiment with a little bit here. Because these endpoints are now, they've been moved around from the center relative to all this information. So we're going to use, we'll use this basically to set up our custom data, and we'll get back to this in a second. Just leave that hanging. All right, so let's put so this we're going to need to tell it what its max and min is. So we'll go to math, max and min, grab those bounds. We're going to have to deconstruct this, right? So math, domain, deconstruct, and we can just put those straight away into there. And the t values are the values that we're aligning along the colors. And yeah, so now we can use this to make our custom previews. So we can just go to display. The geometry is the lines. Turn them off. And the shaders are there. Now in this case, unfortunately, I've got the longest as blue, so all I got to do is reverse those zeros and ones there, and I'll get my, the red highest values to be, the longest line, which of course is the most intense solar radiation throughout the year and all the way around. Okay. So if you have human, we can play with that as well. So I'll turn this off. If you don't worry. But if you do, it's kind of fun sometimes to set a gradient of line weights to this. So the geometry is going to be here. We have our shaders already in place, so we can use those. And so I'll put this over here. This is for Max, and this is for some Windows computers with human. And then I'm gonna. So this is the thickness parameter, and this is only going to take, like we learned before, this is only going to take real numbers, so it's not going to take any decimals, but it's still fun to play with. And give it a gradient. So I'm going to go to set and grab this range. We need to measure the length of the list so that we know how many things we're coloring, and we're going to have to subtract that from 1, or 1 from that, so x minus 1 coming out of there. Yeah. And here we can set our custom domain here. So our range now, let's go to math, construct, and here we can set our top and bottom. So 1 is going to be the default. Actually, you can use a panel for this because that's going to be the thinnest line possible. Anything lower than 1 is just going to disappear. Has no weight. And then we can change this to, I don't know, something pretty big, just for the fun of it. See how that looks. And now our thickest line will get applied to the longest line and the most intense one. Okay, so we've made some custom relationship between the length of the line, the amount of solar radiation, and the graphic here through line weighting. All right, so from thin to thick. And of course, making a change here will give you different results, So this is again, maybe good for screenshots, maybe decent for that, but we should talk about how we could actually bake these line weights or these plot weights and the colors so that you can actually use it in a print direct from Rhino, or you can kind of go ahead and post-process in Illustrator. All right. So that'll be part 2 to this. So we're going to go, and again, those of you without human, I apologize, but if you want to install this on the lab computers, you'll be able to do the same thing if you find this useful for your project. So it's useful to follow along anyhow. So I'm going to go to human, and I'm going to look for this attributes, create attributes component here, the one with the circle, the rainbowy circle. Let's give it a layer. Okay, so we have to, let's see what layers we have set up here. Yeah, I'll just put it on whatever layer. I'll just say layer 01. And it has to be the same, typed the same way. The colors, we already have coming out of the gradients. We can reuse those, right? There won't be any reason for material here because it's just lines. Line type you can set if you like. We can grab a table for that. Let me just fix my viewport here. We'll do that later. Let's go down the line, group indices, don't worry about it. Plot weight, so here's where we can set our plot weight gradient, and for that I'm going to do something similar to this, but make a few changes. So let's grab this, but I want to set a custom, you know, we can grab another one of these for our domain, but I'm going to plug in some different sliders into here because the plot weight is not going to be the same thing as how this component shows you the thickness of lines. They just don't amount to the same thickness, especially if you get, and an Illustrator completely throws it off as well. So this is a little trial and error. I don't have a perfect answer for this in terms of how you might you know, go about really optimizing this process, but I'm going to put a parameter in here of something kind of small like 0.25, and then we'll go with another slider that has some range. So we'll go to edit, make this a little bit higher, like 5, and I'll just kind of put that up a little bit to, like, you know, something over 4. See how that comes out. Maybe a little bit larger. Well, I don't know. Yeah, we'll see how this comes out. All right, so I'm going to leave that on screen just for a second so you can pause it. All right, so that's where I'm at. And now we can plug this direct into the plot weight. All right. And the last thing that I'm going to play with here is the plot color, at least for now. And the color, oh, yeah. This is the object's display color. So this means that it's going to come through, you know, in the Rhino viewport. But also if you want it to plot with that color, so if you're going to print a PDF or something, or if you're going to plot directly to a board, then you're going to want to also plug these into the PC input. All right. So this is pretty much set, and we got to go back to, so to bake it, we got to go back to human, and then there's a component in here with the little fried egg baked geometry. All right, and it's going to ask for attributes, so go ahead and plug those attributes in. The geometry that we're going to bake is the, it's going to be the lines, right? So let me just move this down a little bit, and these lines will come straight in to the geometry here. And now here we can just put a little button on it. So we'll go to parameters, input, button. And every time I hit that button, it's going to bake that stuff into Rhino. Okay. So what I'm going to do is go up to this top little half green cylinder, turn off all this, you know, what this does is it shuts the preview down for everything in Grasshopper. And then I'm going to go ahead and hit that button. Now you can see that I've drawn a bunch of lines. And I can select them in Rhino, and they're all of the proper colors coming out of the gradient. Pretty cool. And they should also all be on that second layer, which they are. All right. Okay, and that'll be one of the first steps in getting at least, you know, first of all, the lines to be drawn along with the data, the colors to come out, because now we can place this in Illustrator for some extra, you know, for some extra stuff. So we can work on that next. So let's see first what happens when I go to print, and probably going to have to update my window here. Just kind of, there we go. So you can see that the, you know, the print color and print weight came through, right? And it came through based on that gradient that I set. Now we're going to have to make some adjustments to this, but I just wanted to show that you can, using Grasshopper, output printable line weights. With a little trial and error, you can get it right. All right. Another way to do this, and now you can take that PDF right into Illustrator if you like, and those weights are going to come with it. So the chunkiness, you know, of those lines will come through, and you can further post-process. Another way, of course, is to just do your old export. Just call this slides or something. And this shouldn't be any new to you, you know, I'm pretty sure. And but just to kind of give you some closure on this assignment here, I'm going to open up Illustrator and look at the graphics. So there's, I opened it up in Illustrator, and this is what I just exported out. So even the export came through with the line weights. So I didn't even have to do the plot. I can use the export command as well, because Rhino is going to take the plot weights along with it, which is pretty nice. And then just to play around a little bit, I'll select all this stuff. I'll throw an arrow on it. Maybe, I don't know, maybe that one. Maybe change the size a little bit because they're a little bit crazy. And put some opacity shift on that. Maybe make them, you know, overlap, kind of nice. Put a multiply on that. And then I want the arrow to be, yeah, right at the end of the line instead of somehow, well, I guess either way is kind of nice. So you can see the accumulation of, you know, of solar radiation through the arrows. You know, it really starts to punch. And the overlap could be strategic. You know, I mean, this is one way for you to show that it gets more intense. And of course over here it's much less intense. So yeah, you know, I'm not going to belabor this point since you guys know how to draw. But again, just looking at one of the first lessons in, I suppose, or one of the first times that we're talking about, at least in the class, on how do you get Grasshopper part of your post-processing workflow. You know, exporting out things for the purposes of drawing and not just for screenshots. Okay, so that's a little crash course on that. And one more thing I guess I'll do while I'm in here with you guys is to just talk about text. Really simple, and Human's pretty good for this, but you don't even need that. So let's look back. Remember we were talking a little bit about these rows values. So what I'm going to do is grab one of these. Remember that we're going to want to use, you know, only the values coming out of. So I'm going to bring that over here so that I could work in this space. And then what I'm going to do is I need to give a location for the text. Okay, so let's first look at our text display option. So we're going to go to display, and then there's a couple different versions of this, and I'm going to use the 3D one, text tag 3D, because this is the one that we can bake into Rhino. And now I have to give it a location. We don't have a point yet, so for that I'm going to select a point somewhere along our lines there. Okay, somewhere along there. It's kind of nice. And I'll just put it over here somewhere and turn that point off because it's going to get in the way. The text itself is going to be all this stuff, those values, and you can see that it's already popping up on screen. We can justify it by right-clicking, maybe bottom center it on the line. That's kind of nice. The colors could change. They can match the colors of the lines themselves, you know, if you want to do that, or you can give it its own custom color. And the size also could change, right? And we can give this a gradient, so let's experiment with that. Right now the size is all the same, and maybe that's sufficient for what you're trying to do, which looks good. But just for the sake of, you know, for the sake of it, we'll put a little gradient on these. And actually, I went a little fast because you can see that there is an issue here. Remember when we did all the sorting? You know, the lines now, remember these lines, are related to the sorting of the data. That's not what I did here. So now I've got values that don't make sense. So I've got 156, which is not my highest value, being applied to my highest line. So we got to fix that, okay? So all we really need to do is grab another one of the, all we got to do is copy and paste, where is it? Yeah, one of these, because this is, you know, again, the resorted stuff. And we're still going to resort everything based on these length values, but the A input's going to change. The A input now, so the K can stay the same, but the A is going to be all these numbers here. All right? And let's see if that fixed it. It looks like it did. So we got our smallest value, 145, attached to the smallest line, and our biggest value of 384 here. Sorry, 388, heading off to the longest. Oh, that's interesting. So that might be an error. I can go back and fix that another time, but you get the idea that you do need those two things to match up. I probably made some basic mistake in here. But in any case, what we're looking to do is put a gradient on the sizes, so the numbers that relate to, you know, the intensity of solar radiation. All right, and I'm just going to once again go ahead with my remapping. So I'm going to go to Math. I'm going to grab that min-max again. I'm going to grab the remap. That's going to be my source. The values themselves are over here. So I'm starting to get a little repetitive, and then yeah, we're going to set a custom, right? Custom in here. And here I'm just going to put, well, actually I'll use a slider. Maybe put that up to 1, and then I'll make another one, and I'll just edit that to be a little higher, because I think I'm going to have to go a little bit bigger. Alrighty, and this should just go right into our sizes. Alright, so those are too big, but we have some control over it now. So go ahead and play with these sliders, maybe reduce them, and our max should definitely get a little smaller. So here you can see now that the size of the text itself is now, you know, again, part of the same narrative here that we've been talking about, which is the annotations are part of the graphic. They tell the same story that the lines do, just through their size. Okay. Okay, that just about, I think, does it for this one. Yeah. We put together a kind of a stripped down custom version of the radiation rose, but really what we were trying to show was how you can get grasshopper and human to work together in order for you to be able to output bake attributes in terms of plot weights and colors directly into Rhino, so that you can do post-processing a little bit faster. Okay? Okay, that's it.